We'll start with problem A first. In this problem, we're meant to print a permutation where the bitwise OR operations of all elements in all subarrays of the permutation is greater than or equal to its length. The first observation in this problem is that the bitwise OR of any sequence of elements will always be greater than or equal to the maximum element in the sequence. This is because if a bit is set in some element, it will always be set in the value of the bitwise OR of some set which includes that element. Once we know this, it becomes easy to see that any permutation works. Let's look at an example subarray of length 5. But then the last element has to be something greater than or equal to 5. A subarray with length I will have to have at least one element that's greater than or equal to I. If we can only fill it with elements from 1 to I-1, by the pigeonhole principle, at least one of the elements have to be repeated. Hence, any permutation works. Let's go to problem B now. In this problem, we're given a grid filled with R's and D's. If we're at an R, we go to the right. If we're at a D, we go down. We need to compute the minimum number of changes such that regardless of what cell we start from, we arrive at the bottom right cell. The first observation in this problem is that regardless of what cell we start from, eventually we end up in either the last row or the last column. Keeping this in mind, let's figure out what changes we need to make to the last row and the last column to arrive at our target cell. If we're at some cell in the last column and it's an R, we need to go right, but that means that we move off the grid and we lose our luggage. So all cells in the last column need to be Ds. This guarantees that we reach our target cell. Similarly, if we're at a cell that's in the last row and it's a D, we move off the grid and lose our luggage. Hence, all cells in the last row need to be an R. This guarantees that we reach our target cell. From this, we can see that the answer is just the number of R's in the last column plus the number of D's in the last row, as these are the cells that we need to change. So yeah, there you go. That's how you solve problem A and problem B. I have video editorials for C, D and E too, so if you're interested, please check them out. If you found this helpful, please subscribe to my channel. I'm not quite sure what kinds of videos I'm going to make yet, but I do think that 3 blue 1 brown style competitive programming videos would be helpful. Please like, share and comment, and feel free to share any suggestions that you might have.